Hi and welcome back. In this video, we're going to deal with UVing our wooden beams. And before we do that, I just want to quickly explain what are we about to do and how are we actually going to do that. So, let's imagine that we have a module that looks something like this. And yeah, well, actually, we're going to have divided pieces, but let's imagine for the simplicity purpose that that is our piece. And it is located in world space coordinates, which is y and x, so world space. However, the coordinates we need are u and v. So that is u and that is v. So uv space. So how are we going to transition this to that? And we're going to use vex, so we're going to do it manually, so to say. So now we need to understand what is the process behind everything. And the first question becomes, what is their relationship? How UV space correlates with world space? So that is a question we need to answer ourselves. And we're going to actually make a variable, which we will call UV space, which will hold exactly this relation. It will hold what is the relation between UV space to world space. It will be user-defined, so the user can change it at any time. But for the example purposes, let's imagine that it is, and that actually is the numbers we're going to use when we will implement it, is 4 by 4. So what does 4 by 4 mean? 4 by 4 means that if this module is 4 in width and it is 4 in height, it will occupy the full UV space from 0 to 1. So that is what it means. And the same if it's like only 2, not 4, but it is 2, then we can logically assume it will occupy only half of our space. And that is already the answer. Because what we're going to do is we're going to look at the bounding box of our piece, disregarding all the cutouts and everything it has, and the world space as well. We will look at its world space width and its world space height. And we're going to transfer that into the UV space by dividing it by our UV space. So UV space, and in this one, since it's width, it's x, and this one, UV space y. So what we will get is the following, and let me grab the blue again. So let's imagine that this, well, I don't know, 2. Yeah, let's make it easy. So 2 by 4 is 0.5. So our bounding box will look something like this. And it is 0.5 and 0.5. So that is our bounding box in the UV space. So we transferred this bounding box, and let me get a thicker line, thicker brush. So yeah, that is our bounding box. So we have that information now. It is a great start. So let me get back to the thinner one. So now what we do, since we already have the bounding box, and again, that's already a hint of what we're going to do next, is we're going to look at the points inside of their bounding box position. So let me grab again another color. Let's say yellow. So we're going to look at this point and we're going to ask ourselves, what is its relative position in the bounding box of the whole shape? And in here, it's 0 and 0. So this one is 1 and 0. This is 1 and 1. And 0 and 1. And this one's, well, let's say that it's 0.3 and, I don't know, 0.4. And this one is 0.6 and 0.4, something like that. So we have all these coordinates in our relative bounding box. So now what we're going to do is we're going to translate these points to the bounding box of this shape. And we already know how tall and wide this bounding box is. So all we have to do now, very simple, is we're going to take these numbers and multiply it with these numbers. So 0, 0 will stay 0, 0, obviously. So 1 and 0 will become 0.5 and 0. And so on. So this 0.3, we will find that once as well. So it will be 0.15 and 0.2 and so on. So we will find all this shape again. So, and there it is. So we did that. That is very nice and well. But if we have all of our wooden beams sharing the same UV space, when we're going to apply shading and texturing, we will see repetition. And that is not what we want. We want every single wooden beam have its own randomized UV space. So how are we going to achieve that? Well, let me grab pink. What we're going to do is we're going to take, again, the bounding box, and we're going to look at how tall and how wide it is. And we're going to calculate how much of free space we still have left. So free space in B, and that is going to be free space in U. And basing on that, we will create, so, a random offset. It can go from 0 to the free space. So it will never be more than the free space we have left, because if that happens, our module will exceed the UV space, and that is not what we want. We want it always to go from 0 to 1. Otherwise, we're going to have seams in our texturing and so on. And that is not what we want again. So that is the way we're going to do it. So hopefully that was informative. And now you have all the information you need to implement it inside of Houdini. So let's start. So here we are inside of Houdini, and we have our beams nicely set from the previous video. And what we want to do now is we want to grab a for each subnet. We will set it to each primitive, yes, and we're going to call it UV here, so it doesn't conflict with our main body loop, and we're going to call it UV vex. We're going to color it, and we're going to dive right into it. And, well, where is my only one primitive, please? Yes, it runs over primitives. Yes, yeah. So now we have this one beautiful beam set up. So let me split our view right away so we can see the UVs. So here we want to set it to UV. And right now it doesn't have any UVs, which is fine. That is exactly how it should be. And the first thing we want to do is we want to create the attribute, because we're going to set attributes instead of our Vex node. So we want to attribute create. We call it UV. And we're going to set it to UV. And it's going to be a vertex. It's very important. And it's going to be a vector. So, and yeah, 0, 0, 0, that's all fine. And the reason we want this vertex attribute is because we're going to run over points. So we will use set vertex attribute function. And that is why we need to create this UV attribute beforehand. So let's grab the Wrangle node. Let's call it UV prim, because we're going to UV is a primitive we're currently running over. And yeah, set over points. That's all correct. So in here, let's bring it bigger. And let's start coding. So the first thing you want to do is we want to convert world space into UV space. So let's say that UV space is the full, let's call it UV canvas size in relation to world space. So we will have that. So let's grab that. It's going to be a vector. So it's a UV space. And since it's going to be user defined, we will create a channel for that, which we will call UV space. So apply, and we will create it right away here. So this is our UV space, and it creates vector 3, but technically we do not need it. So edit parameter interface, we want to need vector 2, and it's still going to be a vector. So yeah, and we're going to set 4 and 4 right away, because that is our relation we want to set. And additionally, we would need a seed because it's going to be randomly placed. So seed. So let's create that right away as well. So that is our seed. Nice and great. And now we want to grab our world space dimensions of the primitive. So for that, we will need to grab an expression called getBoundingBox, and it would require a couple of variables such as boundingBox maximum and boundingBox minimum. So let's create those. And yeah, now we can write that expression. So getBoundingBox, there it is. From 0 index input, and here we input our boundingBox minimum and boundingBox maximum. And now we can get our world space height, which is boundingBox maximum, maximum dot y minus boundingBox minimum dot y. And I'm just going to copy this. And the same way we're going to get our world space width. And that is going to be boundingBox in x. And boundingBox in x. Yes. Great. So now what we want to do is we want to translate world space dimensions into UV space. So float. And now we're going to create UV space height, which is world space height divided by UV space y. And the same was here, UV space width, and this is x, height, and here it's going to be width. So apply and accept, no, not accept, sorry, but no misspells, that's good. So the next step is to create all those UV positions. So let's say get UV positions. So again, we would need a relative bounding box, so relative B box, and we're just going to look at the relative position of our point in the bounding box of its geometry. So 0 and current point position. And now vector 2, which is the position, P position. Oh, well, let's call it actually UV position. And it's a set, because it's a vector 2, we need to set this vector. That is a relative bounding box dot x and a relative bounding box of y. And currently, extra bracket here, and currently this will occupy the full space. So I will actually illustrate you. So if we just do this, and we're not accounting for this world space dimensions into UV space, and I haven't done anything yet. Let's do it like this. So vector UV equals to UV position. I think that should work, and we should see. Yeah, we're actually running over vertices now. So, but it should, yeah, it actually still shows us. And as you can see, our beam fully fit into the UV space. And actually, to illustrate this a bit better, let's find the one with a cutout. Which number that is? 6. So let's blast the number 6. Delete non-selected. And yes, as you can see, we have this cutout, but it doesn't account for the relation between height and width. It just automatically places it inside of full UV space because we are only looking on the relative bounding box position of the point. So now, so let's delete that, and we actually will rename it to a point position, point relative position. And now we can create this UV position, which is again a set. And what we're going to do here is we're going to grab this point relative position and only x. We're going to multiply it with its UV space width. And the same we're going to do, so let me copy that, with our height. So it's y, and this is going to be height. So apply, and now if we do that, so now if we say that our vector UV is UV position. Apply. As you can see, now they are in the same height and width relationship. And the best part is that we have this UV space relation with a world space. So if I put 3 and 3 here, it became bigger. If I put it 1 and 1, it will even exceed, because it will be 1 to 1 to world space. So if it is like 3 in height, this is also going to occupy 3 UV space, but it looks like it's 2 and something in height. So yeah, but 4 and 4 works the best, in my opinion, because we're going to have lots of pieces. So now you were talking about making it random, right? So let's do that. So yes, after we translate world space dimensions into UV, let's create a random UV offset based on the free UV space left. So we would need to grab free UV space height and free UV space width. And those are 1 minus UV space height, because 1 is our maximum, that is 1 and 1. And here the same, 1 minus UV space width. So this is our free height. So now we can easily calculate our random. So float random U, and that is random of our seed, of course. And we want to fit it between its original values of 0 and 1 to 0 and free UV space width. And very similar thing we're going to do for our random V, but with our height. And slightly different random seed, otherwise it's going to be the same offset, so 45. And another thing I want to do when we create our UV position, we just want to add random U, and here we want to add random V. So apply, and as you can see, it moved. So let's check if it works for everything and they never exceed our UV space. So I will actually disable the blast, and currently they are doing it the same for every time. So it's because we have the same seed for each one of them. And that is because we're not accounting for the stamp. We're not accounting what is the loop iteration number is. And we have to do that. We need to account for that. So to fix that, let's edit parameter interface. We will grab a float vector and we will grab a stamp. So stamp. So we need to know which loop are we running through. So we have the stamp, which is a stamp of up of for value UV 0. So that is our stamp. That's correct. And we're just going to add it to our seed. So our seed is channel seed plus channel stamp. So apply and accept, and let's go up. And now, as you can see, they all have random positions. And note, none of them ever exceeds the UV space. So that will be true even if we have it smaller. Still, they would never exceed the UV space, unless, of course, they exceed them. Even if we project them 1 to 1, then of course they will exceed them. But if we even have 6 to 6, they will just randomly scatter. That is great. That works perfectly. And now the last step is you want to convert the attribute from point to vertex. So what we're going to do here is, let's comment it out. Let's say that we want to assign to vertex. And we need to grab the vertex number, which is point vertex expression from 0 index input and point numbers we're currently running over. And then we want to set vertex attribute. Again, 0 index input. We want to set UV. We want to set it on vertex. -1 UV, and set. So apply. And we have a misspell and a set vertex attribute. So yeah, we have 0. We say the name, which vertex we want to do it on. We say that we do not want any element number. Oh yeah, we are assigning just UV. And it should be a UV position. And still. Oh yeah, now it works. So yeah, so now we have it on vertices. So if you go to spreadsheet, and you go to vertex, that is our perfect UV. And yeah, Z. No, we're not going to use it, but yes, UV is here. Beautiful. And so we can go up, and we will do the same thing for this one. But well, currently it's not going to do anything because we don't have anything in there, but let's actually check if it works for absolutely everything. So we have a wood, and yeah, let's go up, and let's test. It should not exceed our UV space. So let's test if it works for everything. And yeah, we see another problem, not a problem, but an issue. It's because our UV loop, and actually our division loop as well, which seems like it, they do not account for the main body loop stem. So let me actually make sure that they do account for this seed as well. So we'll copy parameter, and we'll go back into our wood division, back into our wood, and we will, yes, the seeds, they also need that seed as well. Otherwise, oops, it's transform. Otherwise, it's going to be the same thing for every wall. Yes, every wood beam will be different, but every wall would have the same pattern of that wood, if you know what I mean. So that is why we have to place this main seed as well. So here it is here, and in here. Oh, actually, abort. We have this beautiful seed here. So it's not only have to account for global, but it also has to account for the body seed. So applying the steps. Now this also affects this. So let me delete this one in here. Applying the step, and in this one should be gone. Yes, awesome. And this seed, so copy parameter, and let's delete this transform, should also be in here. So the seed we forgot to connect it. So there it is. So let's go up now, and up and up and up we go. And now yes, that is what I wanted to see. As you can see, they all randomly scattering all around. So let's see if we change the random seed. Let's see if what that would do, and let's change it only for the wood pattern generate. So we go to seed, and we just add 12. Oops. Yes, that works. Beautiful. So that's it for the UVs. So it was quite a short video. And in the next part, we will actually start generating the geometry of our wood and scales. So thank you for watching, and I'll see you very soon. Bye bye.